Hi everyone. Today we will be talking about a very important classification metric, that is the AUC ROC metric, which is any day better than accuracy and F1 score but is rarely used by people. So today we will try to understand what is AUC ROC value and why it is important. So let's get started. So basically, if you look into this particular plot, this is called as the ROC curve plot, where on the y-axis are the true positive rate and on the x-axis is the false positive rate. And this particular graph is the value of the true positive rate and the false positive rate at different thresholds. So basically, when you're calculating accuracy or recall or precision in any of the problem, the default threshold that is getting used is zero point 0.5. So basically, if the probability of the output probability is more than zero point 0.5, you take it as a 1, else you take it as a 0. Now, in not all the cases, the threshold zero point 0.5 would work. So basically, in AUC ROC curve, what we are trying to achieve at different thresholds starting from 0. So a threshold 0 means that if the value predicted is more than 0, it will be taken as a 1, else a 0. And we will be increasing the threshold value and getting the different values for true positive rate and false positive rate of the model at those threshold values. Keep taking it to 1. So starting from 0, incrementing it and taking it to 1, and eventually getting the trade-off between the true positive rate and the false positive rate. This particular curve is called as the ROC curve, and eventually the area that is getting covered by this curve is called as the AUC ROC metric. Now, what is true positive rate and false positive rate? So, talking about TPR, it is a proportion of actual positives correctly identified by the model. So, it can be taken as the actual positives correctly identified upon all the positive detected by the model. Similarly, false positive rate, it is the proportion of actual negatives that are incorrectly identified as positives. So, basically, it was actually a 0 but identified as 1 by the model. So these are the two values, and eventually, as you can see here, ROC curve plot TPR on y-axis against FPR at various thresholds, and the area under the curve is called as the AUC ROC curve. Now let's try to understand with an example. Assume a classification model for detecting a rare disease. So the true positive rate would be the percentage of sick people correctly identified by the model for having the disease, when the model classification is for detecting rare diseases. So if 100 people actually have the disease and the test correctly identified 90 of them, the TPR rate would be 90%. I think it's pretty straightforward because 90 of them were detected out of 100. FPR is basically percentage of healthy people incorrectly identified as the diseased ones. So basically, they don't have any disease, but they have been detected to have the disease. So if there are 1,000 healthy people taking the test and the test incorrectly identified 50 of them as having the disease, the FPR would be 5%. Hence, understanding the AUC ROC curve, if the TPR is high, the test is good at catching those with the disease. If the FPR is low, the test rarely mislabels healthy people. Try to understand these are two different things. It can be the case that the TPR is high, but FPR is also high, and vice versa. Both of them can also be low. The ROC curve shows how TPR and FPR change with different test thresholds that I talked to you about, the different probability thresholds over which we consider whether the label should be 1 or 0. A perfect AUC ROC value would be 100% TPR with 0% FPR. Makes sense, right? So a good test will have a high TPR and a low FPR. An AOC ROC of zero point 0.5 is considered similar to a random guessing. So basically, now I think you should be clear. Zero point 0.5 should be the bare minimum, and 1 should be the perfect value for AOC ROC, where TPR would be very high and FPR would be very low. Now this is good. I think the major purpose of presenting this blog is at times you would be confused which metric to choose to evaluate your model, because there is accuracy, there is F1 also. Now I'm talking about AUC ROC. So I will present you a scenario where AUC ROC would be a better choice as compared to accuracy and F1. Let's get started. Again, we will be considering the same case where we are developing a model to detect a rare disease. Data, we have 1,000 samples where 50 are positives and 950 are negatives. Hope this is fine. Do remember that this is an imbalanced data now because the positive class is rare. assume that we have built two models. One of the model predict all the samples as negative. Hence, all thousand would be negative. All thousand would be given the label zero. While a model B, a classifier with some ability to distinguish between positive and negative classes. So basically, it is able to detect some of them as positives out of the 50 samples present. So any day, if you understand why the text, model B is good. Now let's see how different metrics would be giving you different values. If you look at the accuracy of model A, the accuracy is 95%. Because most of the samples were true negatives, and model predicted everything as true negative. So the final ratio would be 950 upon 1000. Only 50 samples went wrong because 50 of them were true positives, but they were not detected as told, as the scenario we have set. So accuracy would be 95. And similarly, if you, for example, if model B was able to detect 50 samples as correctly from the positive side and some mistakes in the negative side also, the accuracy is still 95. Both the models have the same accuracy, if you can see, but model B is actually doing a better job at identifying the disease. Hence, accuracy isn't a good metric in this case. If you can see, both the values are same, but any day model B would be good because it is able to capture the class of our interest, that is a true positive in case of detecting rare diseases. Now talking about F1 score, precision would be zero as the model won't be able to capture any positive classes. Hence recall is also zero and F1 would be zero. Now for model B, precision would be zero point 0.5, recall would be zero point 0.6 and F1 score would be 0.55. Now I think F1 score has performed comparatively better than accuracy in comparing the models because it is giving us some idea that model B by far is better than model A depending upon the F1 score. But if one problem you can see is that it is not telling you anything about which threshold should have been used because by default the threshold uses zero point 0.5. Is the threshold so a few key points missing when after calculating the F1 score is the threshold used by default zero point 0.5 the best? Overall, how well is the model? So basically it can be the case that the F1 score at this particular threshold is poor, but at certain other thresholds, say zero point 0.1 or zero point 0.2, the model performs exceptionally well. F1 score can give you an idea about the model on a particular threshold only, but not on a wholesome idea. Now talking about the AOC ROC value, since it predicts all negatives, the ROC curve would be a straight line. Now talking about model B, since model B has some capability of distinguishing between positive and negative, assume AOC ROC to be greater than zero point 0.5, that is 0.75 for now. We are not calculating it. So in conclusion, if you see, fails to differentiate between two models, accuracy metrics, so accuracy should be kicked out the first step. F1 is able to show that model B is better, but at what threshold it is not able to make out. Which threshold should be used, it is not giving you any essence. AOC ROC clearly shows that model B is superior in separating the positive cases from the negative ones. I remember a line said by manager that AOC ROC helps you to check whether the model is able to make a classification between the positives and the negatives, how well it is able to distinguish between them. This is the essence of AOC ROC. Now, you would be having question that in case of F1, we are not able to get a ideal threshold. How is AOC ROC helping us with the threshold? So we would be calculating this Jordan's J statistic using the AOC ROC value to check out which threshold is the best threshold to choose for the classification model. So basically AOC ROC value can be used to calculate a specific statistic called as Jordan's J statistic, which eventually helps you to check out which threshold performs the best, gives you the best results. So basically Jordan's J statistics is nothing but checking out at which threshold the difference between the TPR minus the FPR is the best, or it helps you to determine which point is closest to the top left corner of the ROC plot. Eventually, that is the best threshold that we get. Here is a sample code that you can see. So what you can do, you would be calculating the actual, the true labels and the Y scores. You will be calculating the FPR and TPR at different thresholds. And then you will be calculating the Jordan's J statistic. That is the difference between TPR and FPR at every threshold. And for any which threshold the difference is the highest, that particular threshold can be chosen for a classification. I hope this particular tutorial was useful. You are able to make sense of how AUC ROC work, why it is important, and how you can use it to estimate the threshold for classification problems. Thank you.